Now consider the case of inclined penetration. We have considered horizontal and vertical penetrations. Now is the case of the penetration by the inclined object. Consider a case where a cylinder of diameter 80, a cylinder of diameter 80 is penetrated by another cylinder of diameter 50, is penetrated by another cylinder of diameter 50, such that the axis of the smaller cylinder makes 45 degrees with horizontal plane and is parallel to VP. The distance between the axis of bigger cylinder and smaller cylinder is 50 millimeters. It is 15 millimeters, and the smaller cylinder is nearer to the observer. Draw front view, top view, showing the curves of penetration. Draw front view and top view, showing the curves of penetration. So I am starting with the bigger cylinder first, which can be very easily drawn. Then you are required to choose some point on its axis for the front view, and through that point you are required to draw the axis for the smaller cylinder. You are required to draw the axis for the smaller cylinder. So this is how the smaller cylinder axis is drawn, which makes 45 degrees with HP, that means XY line. So the axis has been drawn, and now we are required to draw that cylinder whose diameter is 50. So we will be simply choosing 25 millimeters on either side of this, and will be drawing that cylinder. So we are required to choose. Now you will observe that here the cylinder is going below the horizontal plane, and so we are required to shift this section line up by some distance so that the cylinder can be fitted fully. So let us shift that axis up by some distance. Because that position is also not given to us, so we can easily shift it up. And then we should be having that cylinder fully. So I am taking 25 millimeters on each side of this center line.